Welcome to ConcreteX. Today's guest is Dr. Rolands Cepuritis. He is the Primex CTO. He is also an associate professor at the Norwegian University of Science and Technology, and he's also the chairman of the board of the Latvian Concrete Association. Welcome, Rolands.
Thank you, Kaya. Thank you for the invitation, and if we can learn something more together about the Primex technology.
Well, let's delve into a couple of issues. So in the latest issue of the Concrete Society magazine, there's an article about chemically post-tensioned concrete and the latest research conducted by you and your colleagues. Tell us more about this.
Well, this article is actually like a great milestone in our research activities and development activities, because in this article we presented data that we gathered over several years, where we actually put sensors in our chemically post-tensioned structures all around the world, and we followed the deformation of these slab structures over time. And then we presented the model how the behavior of these structures could be modeled with mathematical approach, because of course following every structure by a sensor is difficult, even though we see that could also be possibly done in the future. And what we find out is that in this chemical post-tensioning technology, the steel fibers, they really work as a very great and rigid restraint, which is able to facilitate the chemical press stressing of the structures. And this is the main aspect, allowing us for designing more slender structures that are more durable and also more sustainable. And this is what we discussed and show in this article.
Okay, and in brief, what would you say, how does this differ from what is most commonly recognized as concrete, or the characteristics of concrete?
Well, this is both familiar and also very different. Familiar in the sense that this kind of approach can be fully compliant already to today's codes, such as Eurocode and industry recommendations, such as, for example, the TR34 recommendation. And also a post-tensioning technology is old and already tested and shows a very nice track record over time. However, doing that by engineering the tensioning force by chemically activating the concrete, this is our expertise, and this is something that we have developed in Primex over the last 10 years.
Roland, tell me more about what the significance is of research and development in the concrete construction industry, because many actually don't have research and development as a part of their fundamental core of services. Tell me about your role.
Well, I would like to answer this question by quoting Wolfgang Goethe. There's a famous quote by him which says that all theory is gray, my friend, but forever green is the tree of life. And what I have basically understood it also by working many years in academia and then back to industry, and now I'm in a parallel position, both in one leg in academia, one leg in industry, is that all the research that we are doing as a mankind, if it's not applied, in many instances, it's just a waste of money. And if we have some very theoretical ideas how we can make construction more sustainable or how we can save resources, but it doesn't make any economical and practical sense to apply it, then it's just knowledge which is maybe forgotten in some published articles. What we try to accomplish in Primex is that we try to be on the forefront of applying the latest findings and finding practical application to them. Because in the end of the day, the society gets better, and it's a better place for our children if we practically do some innovations to make the structures more sustainable. And this is where R&D comes in. Because R&D, Primex, the main idea is that we know what's happening all around the world in academia, on the forefront of our industry, and then we look for practical applications, how to, as fast as possible, implement that in the building site.
And here's a question for you. You said that we apply the latest technologies, but isn't it also that Primex is very often the driving force in innovation? when it comes to concrete technology?
Well, definitely, because well, a lot of companies are just afraid to be the first one. I mean, being the first one is not easy because you always have to explain to your clients. You have to be super confident of what you are doing, and you just have to have the right mentality to do it. And we have that. This is also a part of our R&D culture, because we have a lot of knowledge, a lot of people that can be as internal mentors in the company and then facilitate this process. And this is how we can be on this forefront.
Roland, tell me, why is sustainability a critical consideration in the concrete construction industry?
Yeah, it indeed is, and there are two main reasons to that. So number one reason is that all concrete that we are producing all around the world, the glue component that holds everything together in the concrete is Portland cement. And Portland cement is also a reason why concrete has a gray color. So Portland cement, if you look globally, is responsible for 7 to 8% of global CO2 emissions. And that is, of course, a very considerable contribution to that issue. And the other problem is that, well, the resources that we are using for concrete production, they are by the strictest definition non-renewable. So we take sand out of the environment, we take gravel, and we take also raw materials of Portland cement out of the environment, and they are not renewable. So, of course, we would like to use them to the best possible manner, meaning that we build structures that don't use more resources than needed, and that it's recyclable and we can reuse them as well afterwards. And this is why it's so important. And we talk about it every day in the industry. Everybody wants to contribute to making it greener and make the face of the industry better overall.
And how would you say, how is the industry in general doing in this goal?
Well, depends which part of the world. In some parts it's better than the other, but at the moment it's still quite a lot of talking and not so much of doing, because well, it's nice to put that we are doing something green, but then if you can't find economical means how to pay for that or will to do that, then actually at the moment it's much more, well, I would call it greenwashing than actual activities happening. So in that sense, it's a lot of talking, but not that much of doing.
Following on what you said, that many want to do things, but in practice there's not that much being done. Explain more about how Primex goes about it, because there is a science to it. It is something that can be shown in figures. So if you could explain that.
Certainly. So if you would just go and to a search engine and search for green concrete or sustainable concrete, so the first thing that will pop up, and also a lot of discussions in the industry, is how to replace parts of Portland cement with different other supplementary cementitious materials which have lower embodied carbon footprint. And such materials are fly ash or slag or silica, also called sand clay, would pop up. And this is kind of the most low-hanging fruit that everyone is pursuing. And with today's approach to construction, this allows you to reduce the concrete carbon footprint by maybe 30-40%, but not more. And then also this green concrete that you produce in many cases is challenging to apply. And also another very important thing is that we should remember is that these supplementary cementitious materials, they are only available in limited amounts. So if all concrete in the world would include them, there would not be enough. So it's not possible to transfer all concrete green in this way. And there have been a lot of publications that show that and that talk about resource availability. And they have said that this is just part of solving that issue. Another opportunity is actually working with the structural design. Because if I make, let's say, a concrete slab and the cross section is 30 centimeters, and I only need half of that for actual load-bearing purposes. The rest I include there for some safety of things I don't know, I don't control, I simply don't know how exactly it works. But to be safe, I include that extra margin of safety there. But if I would cut that in half to the actual thickness that is needed for load-bearing capacity, I could save up to 50% more. So that's a great unused opportunity. And if I do that cut down of the suction, it actually means that the volume of concrete I need to pour is less. So all my concreting operations will become more efficient, and I will release less CO2 during those operations. So if we sum all these three things together, a green concrete, more efficient structural design, and more effective construction operations, then maybe you can save up to 70% of the CO2. And more effective design you can apply to any structure anywhere.
And let's talk about collaboration and partnerships. How important is it to collaborate with other stakeholders, with academic institutions, in promoting sustainable concrete practices?
I think it's of a paramount importance, because of course we are just one player, but if you can form a team and you can involve other partners and academia in your research, you actually, first of all, you get a lot of extra knowledge in your projects, in your R&D and development activities, and you also, with the same activity, you inform them about what you are doing, you get their acceptance to that, so that you can faster streamline all the findings in the industry, because they will help you. And I can mention several very important activities going on at the moment where we work together with partners. So one is actually connected to the article that we discussed in the beginning of our structure. So to take it even one step further, we actually decided to build two full-scale elevated slab structures. One with the conventional method, and the other one with the premix chemically post-tensioned concrete technology. And we will test them both for the service load and for the ultimate limit state load, and then essentially test what is the collapse load of both structures. And in this test, which is currently going on, and the results will be published hopefully still this year or beginning of next year, the first results at least, we involve a lot of academic players from different universities, from different countries, and then we have additional consultants from the academia, and we couldn't do it so efficient, so fast without the help of them. Another very important and interesting project is the project we are doing together with the CERN, which is the European Organization for Nuclear Physics Research. And we are together with them looking at how our concrete, which is more sustainable and also more durable, could be applied in nuclear physics institutions and possibly also in the nuclear industry in the future. And we couldn't do that alone, because we are not able to expose concrete to such environments alone without the help of them. And if we do it together, then they see that it works and they are able to apply it faster.
You mentioned full-scale testing, and that's something that's ongoing right now. Is full-scale testing something that's common internationally? Is it common practice?
Well, I would say it like this, that full-scale testing is something that has been known for many years, more than 100 years, because essentially when people started to build the reinforced concrete structures, they had no idea in the beginning how they actually work under the load. So of course they came up with some mathematical models, but then to verify them, they actually build the structure, put an actual load on it, and observe how it deforms and when it collapses. And then with time, of course, because this is a big scale operation, which is expensive and hard to do, then this testing became less and less. And now, of course, I would say maybe several times a year somewhere in the world people do some testing in full scale, but due to the big scale, and also because not so many new technologies come, it's not so common. But well, we decided to do it, and we are the first ones that are doing this on chemically post-tensioned steel fiber reinforced structures. So this is a unique test in that sense. Nobody else has tried that before. I think not only us, but also all our partners which are involved, they are impatiently waiting for the results.
And how could this, say, impress upon, or why would it be important to, say, general contractors or to our end users, the clients? How will this data from the full-scale tests be useful to them?
Well, for them it will just be another very solid reassurance that the technology is working exactly as we calculate and design it. Because actually full-scale testing is something that is fully allowed and included in today's building codes of Europe, in the Eurocode, because Eurocode allows design aided by full-scale testing. And it's not surprising because for many different reasons, for some structures and materials, it's not possible to perfectly mathematically model how they work. So what other choices you have then to not to over-design and spend unnecessary resources? You build it in full scale and you test. And there is no better or more safe mathematical approach compared to that, because then you test it in full scale in reality.
Mm-hmm. And you mentioned the Eurocode. What about other specific regulations and industry standards that promote sustainability in the concrete sector? Tell us something more about that.
Well, I think this is still lagging behind the actual needs because, the standards and also different other trade documents we have, they are very focused on what I mentioned already, the green concrete. The concrete that has less embodied carbon emissions per cubic meter of concrete produced. But that is only one part of the issue, because the actual CO2 emitting thing is the structure. And for structures it's not so clear how to benchmark what is saving and what is not a saving. And this is an issue because this is also a great source of greenwashing, because there is no clear benchmark, and this is lacking, and I don't see it coming so soon. So that's an issue the industry should focus on, and we should work on that together.
And what do you see happening in the next, say, 5 to 30 years? You know, we hear about the European Green Deal, net zero, carbon neutral. What do you see happening in this industry?
I think that, the construction industry has historically been quite rigid. And there is this thing that you hear on the building site where they say, we have been doing it like this for 30 years. And I also have heard a quote recently that nobody has been fired for using well-tested or well-aged technologies. But this will change. And there are several reasons to that. One reason is, of course, the Green Deal, because it's coming. It's coming to the construction industry, and I think there are some legislative activities around the world in some regions, but it will increase, and it will push the construction industry towards the more sustainable structures. But this will come more from the governmental side, also from the user side. But what will also come from the user side, they will demand future flexibility, because we know all the stories of Nokia or Kodak or all these companies, that they were kind of the big flagships of different industries, and then in 10 years time they almost bankrupt. Mm-hmm. And I think that the life cycle of a company will maybe become shorter, because you don't know which parts of your products or technologies will be most demanded in the future. And it means all the buildings, all the facilities you have, maybe they will need different robotics, maybe they will need different other flexibility, how to change them. But of course, a big company, they will not build a headquarter and then fully refurbish it or change it in 5 years. They will demand something that is flexible. So it's future ready, I can change it, I can adapt it to robotics or some needs I don't know myself.
What would you recommend to large-scale companies that are looking for solutions that are not only time-limited to what's happening today, but do allow for that future flexibility?
Mm-hmm. I think it's actually not that complicated to start today, and First thing, look for a partner, a contractor, or any partner you choose that offers design build services. Because if there is one party which is responsible for designing and at the design stage thinking how it's going to be constructed, that is very important. And then, of course, in that process, be involved and challenge any solution that they offer to you, so that any element is done on materials which are most sustainable and most efficient to apply. And then, of course, think about future flexibility. When you compare different solutions for different structures, of course, in warehouse facilities, the most important is the flooring slab structure, because all your business, all your activities are put on top of it, and it has to be future ready and flexible for any kind of adjustments there might come in the future.
And another question for you. You mentioned, that any end user should challenge a cooperation partner with what might be their option. And I think that your involvement in this industry and your experience would also be interesting to learn a little bit about you and how you got interested in this.
Actually, I ended up in the concrete industry a little by accident. I was at that time first year civil engineering student at the university, and for me it wasn't that tough to follow the studies, so I was looking for some part-time job. And then at that time there was an advertisement board at the university, at our faculty of civil engineering, and there was an ad saying that we are looking for a lab assistant for a concrete factory, ready-mix concrete factory, and it says you can do it parallel to your studies and no prior experience is needed. And I say, perfect, I'll take it. So I took it off the wall so nobody else could apply, and called them. And then, okay, some people also had managed to apply already, and then there was an interview session, and I was hired. And I didn't know that much about concrete when I started, and now it's almost, sorry to say, almost 20 years ago. But what really got me excited is actually that when you work with concrete, and one of the main characteristics of concrete is its compressive strength. So to test that, you would cast concrete, which is in liquid form, in formwork, and it would harden, and that formwork has a shape of a cube, and that you put in a pressure machine and check how much load can it take. And for me, it was very exciting, because typically this test you do after 28 days of hardening. So after 28 days, you already see the result of your work, and you see it practically, and it's expressed in numbers. And compared to designing structures, which was kind of my major, which was I was studying, that was more theoretical, because you design them, but you actually never know what load exactly can they take. You have just a theoretical model. But in concrete is what you produce it and you test it, and you see what is the end result, and there is no guessing in that. So that was something that kept me. And then I learned that concrete is such a big billion industry all around the world. There are so many development already at that time was happening, and it was just so exciting. So I decided to stay, and now I've dedicated all my professional career to that.
All right, thank you very much. I'm Kaya Wiesel, and this is ConcreteX.